Welcome to the deep dive. Today, we're cracking open a really fascinating cold case from the ancient world. It's kind of a paleontological whodunit, all centered around this dinosaur called Agrosaurus.
Yeah, and for quite a while, this fella was actually thought to be Australia's oldest dinosaur.
But hold on, because this story has, well, it's got more twists than you'd expect.
Absolutely. We've really plunged into a stack of research on Agrosaurus, looking at its classification, the whole complicated history of its discovery, the identification process.
And the ongoing debate, right, about
Uh,
where it even came from.
exactly. So our mission today is basically to unravel this mystery for you, understand why its origins are so debated, and, well, figure out if it really does deserve that title. Australia's oldest dinosaur? Maybe not.
Expect some surprises, yeah.
Oh, definitely expect some surprises.
Okay, let's start at the supposed beginning. The story, as it was first told, goes that these bones were found way back in 1844.
Right, by members of the HMS Fly expedition. The ship was surveying up near Cape York in Queensland, Australia.
And the story is they're setting up a beacon and, supposedly stumbled upon these fossil fragments.
A couple of tibiae shin bones, a fibula, which is that smaller leg bone, some foot claws, and a few other kind of miscellaneous bits.
Sounds like a pretty standard Aussie discovery story on the surface, doesn't it?
It does. That's what you'd think. But here's the first, let's call it a head scratcher.
Okay.
Neither the expedition's own naturalist, a guy named John McGallifrey, nor the geologist, Joseph Bite Jukes. Neither of them mention these specific finds in their really quite detailed accounts of the whole voyage.
Nothing at all.
Not a peep about these particular bones, and that silence is, well, it's pretty loud, isn't it? It immediately raises a bit of a red flag about this whole Australian origin story.
Yeah, you got it. And this lack of contemporary mention, it leads us to a major plot twist. A really strong possibility that these bones weren't actually dug up in Australia at all.
But much earlier, and in England.
Exactly. The alternative theory suggests that Henry Riley and Samuel Stutchbury, who were known fossil collectors back then, likely picked them up probably in the autumn of 1834.
From the magnesian conglomerate near Bristol, which is, a well-known fossil-bearing rock formation in the UK.
And that's a full decade before the HMS Fly was even sailing anywhere near Cape York.
And you have to think, paleontology in Britain at that time, Bristol was already a hotspot for finding early reptile fossils.
Right. So it's completely plausible that collectors like Riley and Stutchbury would find bones like these there. It fits the context perfectly.
Yep, really does.
So the trail gets even more interesting. These bones, likely from Bristol, they eventually somehow end up in the British Museum of Natural History.
They were bought in 1879 from an Edward Charlesworth who was selling off the collection of someone called Samuel Longwaring who had passed away.
Okay, so a collection changing hands. Makes sense.
Yeah, and they got cataloged, BM&H 4984. But here's the kicker, the bit that sort of blows my mind. They weren't actually studied properly until 1891.
No way. They just sat there for over a decade.
Pretty much. Just imagine potentially really significant dinosaur bones sitting in one of the world's top museums, just waiting.
Wow. That really shows you how science isn't always this, immediate rush to publish, huh?
Not at all. Sometimes things wait. But it also shows that questions do eventually get asked, specimens get re-examined, science kind of corrects itself eventually.
Yeah, sure. Okay, so 1891, finally someone takes a proper look.
Right. Harry Govier Seeley. He gets around to studying these overlooked bones, and he's the one who officially names them Agrosaurus McGillivray.
Honoring McGillivray from the HMS Fly, presumably based on that original, albeit shaky, story.
Presumably, yeah. Though, interestingly, Seeley didn't actually explain the name's origin, the etymology, when he published.
But we think Agrosaurus means?
Well, the general consensus now is it likely comes from the Greek. Agros for field and sauros for lizard. So, field lizard.
Field lizard.
Okay.
And where did Seeley place it in the dinosaur family tree?
He put it within Saurischia. Those are the lizard-hipped dinosaurs, and specifically within Sauropodomorpha.
Which are generally the ancestors of the big, long-necked plant eaters, right?
Yeah.
The early ones.
Exactly. The basal sauropodomorphs. And he narrowed it down further, putting it in the family Thecodontosauridae, which included other early forms known at the time, like Thecodontosaurus itself, from, guess where?
Bristol.
Bingo.
Okay, so Seeley classifies it based on the bones, links it to Australia via the name, but puts it in a group with known English dinosaurs.
It's already getting complicated, isn't it? And it gets more so,
Yeah.
because later researchers started looking not just at the bones, but the rocks stuck to them.
Ah, the Matrix. Okay, fast forward a bit.
Yep, in 1906, we have Friedrich von Huene, a really influential paleontologist. He takes a much closer look at the actual rock these Agrosaurus bones were embedded in.
What did he find?
This is where it gets really interesting. He noticed the rock matrix looked remarkably similar to something called bone breccia found at Durham Downs near Bristol.
Bone breccia. Like fragments of bone all cemented together in the rock.
Precisely. And Durham Downs was already famous for yielding fossils of Thecodontosaurus from England.
Oh, okay. I see where this is going.
So von Huene, seeing this similarity, actually proposed renaming the species the Catodontosaurus mcgillivray. He thought the rock itself was a massive clue pointing away from Australia and towards Bristol.
That's a huge step, saying the rock type matches a specific English location.
It is, and it highlights how important the geological context the surrounding rock can be. Sometimes it's just as telling as the fossil itself.
And this brings up that idea of synonyms in scientific names, right?
Exactly. If scientists decide later that two different names actually refer to the same animal, the older name usually wins out. It has priority.
So von Huene was basically saying, look, Agrosaurus isn't really different enough from the Catodontosaurus, which we already know from Bristol, and the rock matches Bristol too.
That's the essence of it. He was suggesting Agrosaurus might just be another specimen of the already named Thecodontosaurus.
Okay, the plot is definitely thickening now. So did that settle it?
Not immediately. The Australian idea lingered for a while. But then, much later, in the late 1980s, the original block with the bones got more preparation work done. More cleaning, exposing more detail.
And that led to new insights.
It did. In 1991, Ralph Molnar looked at it and noted similarities to Massospondylus, another early sauropodomorph. And even before that, back in '76, Galton and Cliver suggested it was close to Ankylosaurus.
So people were still debating exactly which early sauropodomorph it was, but the British connection was looking stronger and stronger, especially after von Huene's work on the rock.
Definitely. The focus was shifting. But the real, I guess you could call it the smoking gun, or the piece of evidence that really hammered home the British origin, came a bit later.
Okay, lay it on us.
Research published in 1999 by Vickers-Rich, McNamara, and Milner. They went further than von Huene. They didn't just say it was the Thecodontosaurus, they specifically argued it was synonymous with Thecodontosaurus antiquus, the main species from Bristol.
And they even suggested the museum records might have just been wrong, like mislabeled from the start.
That was part of their argument, yeah.
Yep.
But maybe the label associating it with the HMS Fly in Australia was just an old error that got perpetuated.
But did they have new evidence, besides just re-examining the bones in the rock?
Oh, yes, and this is the clincher. During their re-examination of that original fossil block,
Yeah.
they managed to extract tiny jaw remains of a sphenodont, that's a type of reptile, distantly related to lizards and snakes, like the modern tuatara.
Okay. A reptile jaw found with the dinosaur bone.
Exactly, from the exact same rock matrix. And this sphenodont wasn't just any reptile. It turned out to be identical to Diplodocus avonus.
Diplodocus avonus. Doesn't ring a bell for me. Is that significant?
Hugely significant, because Diplodocus avonus is a reptile species that is commonly found. Guess where?
Let me guess. The Triassic rocks around Bristol.
You got it. It's practically a signature fossil for those specific geological beds in England, finding it cemented in the same piece of rock as the Agrosaurus bones. Well, that's incredibly strong evidence.
Wow. Okay. That's not just circumstantial anymore. That's like finding a suspect's fingerprint at the crime scene.
Pretty much. It directly links the Agrosaurus material to a specific time, the late Triassic, and a specific place of the Bristol area. It effectively dismantled the Australian claim.
So that discovery, the Diplodocus jaw, that was the real turning point.
Absolutely. It convinced most paleontologists. The interpretation that Agrosaurus was actually a British Thecodontosaurus specimen, likely misidentified or mislabeled way back when, is now pretty much accepted in most scientific literature.
Okay, so accepting it's likely British and probably a Thecodontosaurus. What did this animal actually look like, based on those original kind of scrappy bones?
Well, based on those fragments, the leg bones, claws, bits and pieces, scientists estimate the living animal was probably around 3 meters long, so about 10 feet.
Decent size for an early dinosaur.
Yeah, not huge like later sauropods, but respectable, and its overall appearance would likely have been that classic early sauropodomorph shape. Meaning a fairly bulky body, a reasonably long neck compared to other dinosaurs of the time, a relatively small head. And feet with claws.
Yeah.
Probably walked mostly on its hind legs.
Bipedal and diet. Still plant-based.
That's the general thinking for basal sauropodomorphs like Thecodontosaurus. Primarily herbivores, munching on plants, but, maybe omnivorous, possibly supplementing with insects or other small animals. It's hard to be absolutely certain from just bones sometimes.
Sure. So what's the final status of the name Agrosaurus itself if it's really Thecodontosaurus?
Well, officially, the name Agrosaurus is now generally considered a nomen dubium.
Right, you mentioned that term earlier. Remind us.
Nomen dubium basically means dubious name in Latin. In paleontology, it means the original fossils the name is based on the holotype are too incomplete or poorly preserved.
Too scrappy.
Yeah, too scrappy, essentially, to be certain that it represents a distinct genus, or even to reliably compare it to other finds. So its validity as a unique name is questionable.
And it's also considered a junior synonym.
Often, yes. A junior synonym of Thecodontosaurus, meaning Thecodontosaurus is the older, valid name based on better material, so it takes precedence. Agrosaurus becomes just another name for the same thing, and the less preferred one.
Got it. So the title of Australia's oldest dinosaur is now vacant, essentially, since Agrosaurus got disqualified.
Pretty much. And that title, based on current, well-documented evidence, seems to belong to Rhedosaurus and Ozraptor.
Rhedosaurus and Ozraptor. And when are they from?
They're quite a bit younger than Triassic Agrosaurus would have been. They're from the Middle Jurassic period, specifically what's called the Bajocian Age.
So Jurassic, not Triassic.
Yeah.
A different chapter in dinosaur history entirely.
Exactly. So while the Agrosaurus story is this really tangled, fascinating detour with all these twists.
A proper paleontological mystery tour?
Right. The actual oldest confirmed Aussie dinosaurs we know about so far come later in the fossil record.
Okay, so let's wrap this up. Our deep dive into the Agrosaurus mystery. It's been quite a ride. From that initial shaky Australian connection.
All the way across the globe, essentially, to the fossil beds of Bristol, England.
And through, what, over a century of scientific detective work? Looking closer at the bones, the rock.
And then that killer clue, that tiny Diffidonnosaurus jaw, that really was the aha moment, wasn't it?
Absolutely. The smoking gun, like we said, it just perfectly illustrates how science works, though. How understanding of the past isn't static.
Not at all. It's constantly being refined, challenged, updated. Even fossils that have been sitting in museums for ages can have their stories completely rewritten when new evidence pops up or we develop new ways to analyze them.
Yeah, it really hammers home how important it is to keep questioning assumptions, right?
Yeah.
And to look at all the different lines of evidence, the bones, the rock, the associated fossils.
Definitely. You need that multi-pronged approach in paleontology.
And it really makes you wonder, doesn't it? If just a few mislabeled bones, maybe a slightly ambiguous old record, could lead to this whole fascinating decades-long paleontological puzzle.
Yeah.
Well, what other incredible stories might still be hiding, tucked away in museum drawers around the world, just waiting for someone to take a closer look, ask a different question, and maybe completely reinterpret them?
That's a great point. It's a potent reminder that our understanding of Earth's deep history is absolutely still unfolding. It's a dynamic quest, and there are probably plenty more surprises waiting to be found, maybe even in places we think we already know well.